Hello again, guys, and welcome to my channel. This is Chemistry by Austin Munara. This is episode 7, and it's called Astrochemistry. So, in today's episode, we're going to look at astrochemistry, everything it involves. Well, as a brief description, I would refer to as where astrophysics and chemistry are combined, astronomy and chemistry are combined, so that you could study chemistry in the universe. Stuff like everything in outer space, like molecules, like atmosphere, you name it, right? Chemistry chooses to observe such phenomena in interstellar, all of those things, right? So, without further ado, let's get right into it. So, astrophysics is the disciplinary science that tries to understand the chemical process that determines the composition of gases and interstellar dust particles, right? That's the definition. It's the disciplinary science that tries to understand the chemical processes that determine the composition of gases and interstellar dust particles. So, the chemical process that are current in interstellar gas regulates the information of stars and planets. Dust particles are the raw materials which the planets are formed, right? So, up to there, you've been acquainted with the definition and what astrophysics is really about and what it entails and what it aims to do. So, let us go on. How do we determine the chemical composition of objects which are very far from us? Well, this is through Viscoprisky or data analysis of the emission of the spectrum of the stars, planets, and interstellar media. This analysis allows us to observe the chemical composition. This analysis allows us to observe the chemical composition, right? Each chemical element has a characteristic emission spectrum that can be identified. In the case of the interstellar media, the emission spectrum in the far infrared that can be used. The analysis of the spectrum of the backroom light allows us to invert the up on the amount of the material in interstellar clouds, right? So, in the case of the atmosphere of the planets of the solar system, they are investigated using the refraction spectrum of the sunlight on the planet. Whoa, am I right? In the case of stellar atmosphere, it is investigated using physical and ultraviolet wavelength. These are some of the methods which we investigate. This is how we measure and do astrochemistry, right? These are some of the techniques that are being used today to be able to practice chemistry at that level, and yeah, those kind of locations. So, astrochemistry is a vortex because it can understand the formation of complex molecules such as amino acids and formation of life on our planet and the universe. So, so far that was astrochemistry. In astrochemistry, we choose to look at such things as like debris in outer space, those dust particles, interstellar dust particles. There's a lot that we choose to look at and study. For example, let me give you an example which the experts explain. You could be in a space station in the moon and you try to mix and you try to mix sugar with water. Now on earth you mix sugar with water and it just dissolves, right? Perfectly. But in a space station, in outer space, the water would get out of the glass because of no gravity, and it would fall a ball like shape, which would be destroyed if tampered with or penetrated, right? And it would make it almost impossible for you to mix sugar with water, or even if the water remained in the glass, the sugar would have a hard time to dissolve because of gravity. This is some of the chemistry that we choose to understand and study. So there's a lot of astrochemistry out there. It's a beautiful lane which we can study astronomy and use chemistry. Be sure to check out some of the YouTube clips that are out there, what the experts say about astrochemistry. This is a brief introduction into the astrochemistry world by Austin Monara. I hope you loved it. I hope you've enjoyed it. Make sure you do your follow-up studies. If it wasn't enough, there can never be too enough of these things, am I right? So yeah, until we meet again next time, Austin.